welcome to Algebra Online. Today we're going to learn how to solve absolute value equations. Super exciting. I want you to be able to know how to isolate the absolute value first before we write two separate equations. Okay, so wait. First. Did you write a title on your notes? Yes? Did you write the 3-3-1 absolute value equations? Okay, if you did you write down the learning target? So that way when you look back in your notes, you know exactly what we were doing, not just the title. Yes? Okay, now we're moving on. Okay, so I would like you to write down this equation. I know it looks pretty big, and I know it looks kind of difficult, but I believe in you. I know you got this. Let's use a lot of the strategies that we've been learning throughout the year to solve this equation. Okay, so pause me, write it down, and then let's go ahead and get started. So I notice on each side of the equal sign that we have two binomials that are multiplying each other, see no sign there, and then we have two binomials that are multiplying each other, no sign there. And so I can separately treat these two as the FOIL method, double distribute. You could do the area or the box method, your choice. So I'm just going to go ahead and kind of double distribute or FOIL in my head a little bit, and I'm going to say first times first is x squared. Then the outers is 4x plus the inners is 3x plus the last are 12. And I'm going to do the same to the other side. So I have x squared plus an x plus 2x plus 2. And then I am going to look and see, do I have like terms on each side of the equation? And I do, right? We know that the 4x and the 3x are like terms. And on the other side of the equation, we know that we have an x and a 2x. Now, notice how I circled the sign in front. That's really important because sometimes we forget the negative sign or the subtraction sign that's in front. And then next thing you know, we are not combining correctly. So it's just always a good idea to, when you're combining like terms, to include that sign when you're either circling or highlighting or however your strategy is that works for you. Okay, so now I'm going to write down I have x squared plus 7x plus 12 equals x squared plus 3x plus 2. Awesome. So don't get scared about the x squareds. There's one on each side. And if I were to subtract the x squared from each side, they would simply cancel. And so therefore I'm left with 7x plus 12 equals 3x plus 2. Now I know you guys are really good at this, and you know that I always like to move the smallest x first. You don't have to. You can move any other term that you want to, but that's just a strategy that I do. I subtract the smallest x first, and then it guarantees me that leading coefficient there is positive. So now I have 4x plus 12 equals 2, and I'm kind of running out of space. I wrote too big. Okay, so if I were to subtract the 12, hopefully you can still see that. What's going to happen is here, I will leave myself a little space. I'll switch up my color, and I'm going to say, I'm going to continue right here, and it would be 4x equals a negative 10. Did you see that? Because I have 2 and a negative 12, and I'm subtracting it to the other side. Good. Now, I know you're thinking we probably did something wrong because it doesn't divide perfectly, and we didn't do anything wrong. Sometimes our answers are going to be messy, and that is okay. I don't want you to be alarmed if you don't get a nice, pretty integer as your answer. You know, those messy numbers are fun, and they're okay. Now, I know that x can be simplified. It's definitely a negative, but 10 over 4 can be simplified to 5 over 2, and we are done. Whew, okay, so that's not an absolute value equation though, right? You don't see those absolute value bars at all. No, that's just kind of taking what we've been learning about multiplying binomials and having an equation and seeing the beauty that happens there. Okay, so now we're at absolute value equations, and I'd like you to take a minute and please write these three down for sure, and then I want to talk to you about them. So the first one is the absolute value of x equals 5. What it's asking you is what are the possible values that x could be? Now, we know that anything inside of those absolute value bars must be positive. because absolute value is the distance away from the number line, right? And distance can't be negative. We're still taking steps in either way on the number line. So we know that our answer here must be positive. So technically, what if I put in the absolute value of -5? Will that equal 5? Yes, right? Absolute value of -5 just says that -5 is 5 steps away on the number line from 0. So x can be, and so I'll write this down here, x can be a -5. Now, I know you're probably thinking x can also be 5, right? Absolute value of 5 is 5. Yes, you would be right. And so we would say that x could be -5 and a +5. All right, so then same situation, even though the numbers are really large, that's 133 steps away from 0 on the number line. So x can be a -133, which means I can take -133 and plug it into this equation and it will make that statement true. And then x can also be a +133. All right, so the last example here, I want you to notice something. This example is telling you that anything that goes inside of this absolute value, anything that we plug in for x, and we take the absolute value, gives us a -2. Well, that can't happen, right? We cannot plug in any number for x and have it to be equal to -2 because this is representing absolute value. Absolute value is telling the reader this is how many steps away from the number line, and we can't move a distance of negative. I mean, you can walk backwards negative, but you're still taking 2 positive steps. So this is just not possible. So no, there's no valid solution for x. No solution for x. We cannot plug anything for x to make that statement, that equation, true. Okay, so now let's take a look at something just a tad bit more difficult. What do you recognize? What do you notice? Well, we got some stuff going on inside of the absolute value bar, which we haven't seen yet is this far in math. So I want you to think about whatever we plug in for x, right? And do this math, and it's going to be the distance away from 0 on the number line, but we need to represent both negative and positive away from 0, right? Because absolute value represents both distances, even though they're positive. And so in order for us to represent both distance from 0, negative and positive, what we need to do is we need to break this up into 2 separate equations. Now, when we break it up into 2 separate equations, the absolute value bars go away. Why? Is because we're going to write one that's going to equal a +10 and the other one's going to equal a -10, and that's going to represent the distance away from 0. So I'm going to say x minus 7 equals a +10 and x minus 7 equals a -10. Always one will be positive and one will be negative, and the absolute value bars go away. All right, so now we can solve them separately, and so I would say I could add 7 to each side, and x can be 17. And then I can add 7 to each side here to isolate the x, and I would say that x is a -3. So I have both of these are 2 possible answers. When I plug them into my absolute value bars, it makes this statement true. All right, so let's take a look at another example. I recognize the absolute value bars on this side of the equation are by themselves. We don't have any other numbers we have to worry about. They are completely isolated. Now there is things inside, and I bet you might be thinking, so I'm kind of like guessing, like what would a student raise their hand and ask? Would you be asking about this negative? Would you be saying, hey, do we have to change this to positive because anything inside of the absolute value bars is positive? No, that stays true. That stays true to this equation, and you're right. We'll make anything inside of this going to be positive with whatever we find for x. But when we break it up into 2 separate, this holds, this stays the same, because when we break it up into 2, one will be positive and one will be negative with the 16. All right, so I'm going to right away break it up into 2 separate equations, drop the absolute value bars, because we're going to represent distance with a +16 and a -16. And then we're going to solve them separately. So you guys are going to add 5 to each side. You're really good at two-step equations. I know, I've seen you guys. So 3x equals 21. And when we divide by 3, x is 7. Good. And then let's add 5 to the other side here. I have 3x equals negative 11. And when we divide by 3, oh, we got a not fun. I think it's fun though. You guys would say it's not fun, but I think it's fun. So x is a negative 11 over 3. I can't simplify that. I'm not going to convert it to a mixed number. You know, we love improper fractions in Algebra 1, so we're just going to leave it. And that is it. Okay, so I'd like you to write this problem down, and I want you to notice what looks different about it from the other two examples. Well, yeah, it's got this 8 right here, right? Yeah, there's something on the outside of the absolute value bars on this side, on that side of the equation. There's an 8 there. So very important, if you recognize that there is other parts of the problem that are outside the absolute value bars, we cannot break it up. We can't, unless the absolute value is isolated by itself on one side of the equation. So what we're going to have to do is we're going to have to get rid of that 8, and we're going to have to divide by 8. Now, why divide? Why couldn't we subtract by 8? Well, there's no sign between the 8 and this absolute value bar. No sign. Now, you guys know that if there's no sign, we are multiplying. And the inverse or opposite of multiplying is dividing. So once we divide by 8 on each side, then very, very careful. I always see students do this. Don't drop the absolute value bars yet. I know it seems tedious that you got to write it down again. And 80 divided by 8 is 10. I know you want to stop, skip that step. Don't. It'll get confusing. Also, when you're writing these absolute value bars, kind of make them a little bit bigger so they don't look like a 1 or part of the problem that's not the absolute value, instead of it looking like it could look like a number basically. So I like to make them kind of big or bold. That'd be a good idea. So now I have the absolute value bars by themselves, and so now I can break them up into two separate equations. So I would say negative 10n equals a positive 10, and a negative 10n equals a negative 10. Now divide by negative 10 on each side, and we have our two possible answers that will work with this equation. So n can be negative 1, and let's divide by negative 10 here. And, oh, keep the negative, and n can be a positive 1. That's cool how that worked out. Alrighty, so let's take a look at this problem. Do you notice anything outside the absolute value bars? You should be saying yes. You notice that this is a negative 7, and you know that we need to move it to the other side. Now, when we move it to the other side, because there is a sign between the bar and that 7, it's a negative sign, so we're going to add 7 to the other side. So I'm going to add 7, and then I'm now going to rewrite my absolute value of n minus 1 equals a positive 6. Now you can break it up into two separate equations. I don't know why I just had a weird sound effect there. And that's m minus 1 equals 6, and m minus 1 equals a negative 6. And let's solve them individually. Plus 1. M can be 7. And let's add 1 here. And m can be a negative 5. Are you ready to try some out on your own? I think you are. I think you got this. All right. And if you struggle a little bit, that's okay too. I want you to pause this video, and I want you to try these out on your own, and I want you to press play when you're ready. And if you struggle or get lost, or maybe you were zoning out during my video, like some students say I was watching and then I started thinking about something else, and then I was like lost, and it's hard to stay motivated. I totally get it. But I believe in you, and you got this. All right, so pause the video, try them out. Okay, here we go. How'd you do? So I noticed that the first one is isolated all by itself, so I'm going to separate it to two separate equations right away. So n minus 4 equals 8, and n minus 4 equals a negative 8. Then I'll just solve them individually. I'm going to add my 4 to each side, and I'm going to say that n is 12, and can be 12. And then I'm going to add 4 to the other side here, and n can be a negative 4. Okay, cool. Last problem of today, and it is that negative 5 is multiplying the absolute value of n minus 1. So I'm going to do the inverse opposite, and I am going to divide by -5. Now that leaves me my absolute value of n minus 1 equals, and that's going to be a positive 9. Perfect. Because it is positive, I know that I can move on. If that was a -9, no, we done, but we're not. We're keeping going. So I'm going to break this into two separate equations, and it is going to say n minus 1 equals 9, and n minus 1 equals a -9, and we'll solve them. We're going to add 1 to each side, and n is a positive 10, and then add 1 to the other side, and n is a -8. All right, guys, I really hope that you enjoyed today's lesson, and I'll see you next time. Bye.